In the grand tapestry of the cosmos, few phenomena capture our imagination like black holes. These mysterious entities with their immense gravitational pull have fascinated scientists and stargazers alike for decades. They represent the ultimate unknown, a place where the laws of physics as we know them break down. These enigmatic objects, where gravity reigns supreme, are formed through some of the universe's most intense processes. The journey to understanding black holes begins with the life cycle of stars, those brilliant beacons of light scattered across the night sky. Let's begin with the birth of a black hole. The story starts in the vast stellar nurseries where stars are born from clouds of gas and dust. Over millions of years, gravity pulls these clouds together, forming a protostar that eventually ignites nuclear fusion in its core. It all starts with a massive star, much larger than our sun. These colossal stars, often tens or even hundreds of times more massive than our sun, live fast and die young compared to their smaller counterparts. Throughout its life, this star undergoes a series of nuclear fusion reactions at its core, converting hydrogen into helium and eventually into heavier elements. This process releases an enormous amount of energy, which counteracts the force of gravity trying to collapse the star. As the star exhausts its nuclear fuel, it can no longer support the weight of its own gravity with the pressure from fusion reactions. The balance between gravity and pressure tips, leading to the star's inevitable collapse. This is when things get dramatic. The core of the star collapses under gravity's relentless pull, causing temperatures and pressures to skyrocket. The outer layers of the star are blown away in a spectacular explosion known as a supernova. The core collapses under gravity's relentless pull, and the outer layers of the star are expelled in a colossal explosion known as a supernova. This explosion is one of the most energetic events in the universe, briefly outshining entire galaxies. But what remains is even more astonishing: a black hole. The core's mass is so concentrated that it creates a singularity, a point where gravity is infinitely strong and space-time curves infinitely. The core's mass is so concentrated that it creates a singularity, a point where gravity is infinitely strong and space-time curves infinitely. This singularity is surrounded by an event horizon, the boundary beyond which nothing can escape. Around this singularity forms an event horizon, the boundary beyond which nothing can escape. This event horizon marks the edge of the black hole, a point of no return for any matter or radiation that ventures too close. This event horizon marks the edge of the black hole. Anything that crosses this boundary is pulled inexorably toward the singularity, where it is crushed to infinite density. Anything that crosses this boundary is pulled inexorably toward the singularity. Not even light can escape, which is why black holes are black. They're invisible against the backdrop of space. Their presence is only inferred through their gravitational effects on nearby objects and the radiation emitted by matter as it falls into the black hole. Not even light can escape, which is why black holes are black. They're invisible against the backdrop of space. However, their immense gravitational pull can bend light around them, creating a phenomenon known as gravitational lensing, which can reveal their presence. Black holes can also form from other processes. For instance, when two neutron stars orbit each other and eventually collide, they can create a black hole. These collisions are cataclysmic events that send ripples through the fabric of space-time, known as gravitational waves. For instance, when two neutron stars orbit each other and eventually collide, they can create a black hole. The collision of these incredibly dense objects releases a tremendous amount of energy, often resulting in a gamma-ray burst, one of the most powerful explosions in the universe. Or, in the early universe, primordial black holes might have formed from density fluctuations shortly after the Big Bang. These black holes, if they exist, could be remnants from the very beginning of the universe, offering clues about the conditions of the early cosmos. Interestingly, black holes can grow by accumulating matter from their surroundings. This material, often in the form of an accretion disk, spirals inward, adding to the black hole's mass and sometimes emitting powerful radiation in the process. The intense gravitational forces heat the infalling material to extreme temperatures, causing it to emit X-rays and other high-energy radiation. This material, often in the form of an accretion disk, spirals inward, adding to the black hole's mass and sometimes emitting powerful radiation in the process. These emissions can be so bright that they outshine entire galaxies, making black holes some of the most luminous objects in the universe. In the vast cosmos, black holes play a crucial role in galaxy formation and evolution. Supermassive black holes, millions or even billions of times the mass of our Sun, reside at the centers of most galaxies, including our own Milky Way. Their gravitational influence can shape the orbits of stars and the distribution of gas within the galaxy. They can influence the movement of stars and gas, and even emit gravitational waves when they collide with other black holes. These waves, ripples in the fabric of space-time, were first directly detected in 2015, opening a new window into the study of the universe. From the collapse of massive stars to the merging of cosmic giants, black holes remain one of the most intriguing and mysterious elements of our universe. Their study not only helps us understand the life cycles of stars, but also the fundamental nature of space, time, and gravity. As we continue to explore the depths of space, these cosmic enigmas will undoubtedly reveal even more about the nature of existence itself. The mysteries of black holes challenge our understanding and push the boundaries of science, inspiring us to look deeper into the cosmos. Discover the wonders of the universe. The journey to understanding black holes is far from over, and each new discovery brings us closer to unraveling the secrets of these fascinating cosmic phenomena. Explore more.